All right, so in the previous video, we selected our signals for channel 1 and channel 2, but I want to make a quick recap on all the different things that happened at, the input probe, from the input probes all the way up to this point, because after this point, we're going to be performing a bunch of operations in parallel, so this is a good time to recap everything that happens before that. So at the very start, we had 4 probes, but I only showed 2 of them because the simulation time was too long to run all 4 probes. So I only showed 2 probes, and we used those 2 probes to measure 2 points in a full wave rectifier circuit. Now, each of those probes generated 3 different signals with different voltage divider ratios. And so that was the analog probe part. And there's also an anti-alias filter in there to filter out signals with too high frequency. And then in the next part, we selected which of those 3 voltage divider ratios we wanted to use for each of our probes. Now, normally this would be set for all 4 probes, but since I only used 2 probes, so we set the voltage divider ratio that we wanted for the 2 probes, and we chose a voltage divider ratio of 1 to 10. So that way the max input would appear as about around 2. And then the next part after that, we chose which of the probe inputs we would use as our channel inputs, because normally with 4 probes, you'd have 4 different voltage selections to choose from. And from there, you'd have to choose 2 of them to be actually used and observed by the system. Since I only did 2 probes, then I just set probe 1 as channel 1 and probe 2 as channel 2. But originally, with probes 3 and 4, you could have chosen to put probe 3 or probe 4 as channel 1 or channel 2 as well. And so after the channels have been selected, the system will perform a bunch of operations on the channel inputs. And I talked about how the channel 1 is the primary input, and all single signal operations such as integration, differentiation will only be performed on channel 1. But some of the other operations such as addition and subtraction require 2 inputs, and so they would use channel 1 and channel 2. But this next operation we're going to talk about, but there's another operation that our system performs, and that's just simply letting the signal pass through. And that's because if you think about an oscilloscope, sometimes you don't want to perform any operations on your signals. You just want to see what you're measuring at that point. So with that in mind, this is basically no signal or no operation on the signal, or inverting the signal, because some oscilloscopes also have the ability to just invert the signal that it's looking at, if in case you need to invert it because you ran it through an inverting circuit or something. So this circuit right here performs a very simple operation. It either lets the signal pass through normally, or it will invert the signal at the output. Now, it looks a little backwards at first because it looks like this is an inverting amplifier with a gain of 1 because these resistors have the same value. But the pass-through has this inverting buffer right here. And the reason why the pass-through has the inverting buffer is because at the very end of our system, the signal gets inverted another time. So that way, that inversion will cancel with this inversion, and so then it will come out normal. And if you look over here, the inverted ones, they go through a simple buffer without inversion, and that's because they get inverted at the very end to become inverted. So now with this, we just have to input the channels, channel 1 and channel 2 into these. This is done the same as normal. You just open them up, open up the text files that we made previously. So this is the channel 1 signal we made in the last video. Load that up. In here, we did the piecewise linear function, this one. Open it up. Channel 2, the channel 2 signal that we made earlier. All right, so we have channel 1 and channel 2 in there. And then all I have to do is simply run this transient for 1 millisecond. As a small important note, okay. A small important note, plus or minus 12 volts is the same throughout the entire system. And so if we look at our signals at the output, they're all right now scrunched on top of each other, but I can separate them all out using separate curves. And so if we look at it, the channel 1 invert looks not inverted right now. The channel 1 pass-through does look inverted, but like I said, at the very end, these will get inverted again, similar with channel 2 invert and channel 2 pass. So right now, all we need to do now is export these as text files. This is done, and then I'm going to name these as pass-through operations. So I'm going to save them as that. All right, minimize that. All right, open them up now in Excel to go and process them. So if we open up those probe inputs that we looked at, or not those probe inputs, those pass-through operations right here, we open them up. Again, it's tab delimited. All right, finish that up. So we have 4 four input outputs that we need to separate, we also need to look at the number of samples. So notice how, again, every time we run a simulation, we get 10 times as many outputs as we do inputs. So again, we're going to have to filter out every 10th sample to make sure that the number of samples is low so that way the simulation time doesn't take too long. So again, I'm going to use my macros, and I'm going to use the filter samples to filter out every 10th sample. And so then I'm going to overwrite these previous ones with this new data. All right, and now I just need to save all of these as text files. So I save these as text files with tab delimited because Tina only reads tab delimited. This is the channel 1 pass. I'll save that. All right, close that one out. This is the channel 2 pass. Again, tab delimited. Save that, replace that. Good to go. This is channel 1 invert. Tab delimited. Save that, replace that with new data. And then channel 2 invert. This is tab delimited. Save that, replace that, close that. All right, this is the original file. All right, so that's all that's done for this operation. Now the outputs from this operation will all lead to the output. But before we get to the output, I want to cover each of the operations done in parallel before then. So the next couple of videos will not deal with these outputs, and we won't deal with these outputs till the very end. But I want you to just remember that we have a bunch of outputs that we have to choose from at the very end. So in the next video, we'll cover more of the operations in parallel. And then once we're finished with all the operations in parallel, we will start talking about what to do with these outputs.